Had some questions recently on how ChatGPT actually works. So in today's lesson, I thought I'd teach everyone, like, technically what it is that ChatGPT is doing behind the scenes. So we jump in. Here is an example of some text that we might feed ChatGPT. So the weather is, and then what it's doing is it's predicting the next word. It's actually predicting the next token, but it's predicting the next word that's most likely to come in what it's seen previously. And actually, so probably what happens most commonly is nice, but there's several examples. It could be nice, it could be hot, it could be cold, it could be windy, it could be sunny, it could be raining, it could be snowy. But based on previous experience, the next word based on all of those words previously could be any of these. But on top of that, not only could it be any of these possible words, additionally, like, there's a percentage of chance of how often this has happened. So this has happened 60% of the time, this has happened 20% of the time, this has happened 10% of the time. I can do the percentage sign. This has happened 5%, this has happened 4%, and so on. And like, as we go down the list, like, these start to happen like fractions of a percent at the time. But these are all things that it's seen before. This is how it got trained. So all they ultimately did was they took a bunch of results from the internet. So I'm from Southampton, if you didn't guess that. We need something better than this. We need something that's got lots of text. So let's just pick a news report. So they've taken a whole bunch of documents from the internet and they've just pasted it into the training data. And the training data has basically gone, when the previous word is, I think he spent most, the next most likely word is of. And then based on all of that being the previous word or previous words, last might be the next most common. And then based on all of that being the previous words, year might be the most common. And it keeps going. So it's always looking for the words or the tokens that have appeared before it. You might have noticed that I keep saying tokens rather than words. So what's going on there? And the reason for that is the way the bot or the AI has been trained is based on different things that it can possibly see. So that could be a token, or it could be that, I just saw a really good example in the text a minute ago. Yeah, so that could be a token, and then ed could be a token, or ing could be a token. There's a big list somewhere inside ChatGPT. In fact, some of the libraries do expose it. Tick token. But what we're really looking for is, when I've seen all of this, like, what's the next most likely thing? And in this event, assuming this is what got produced by ChatGPT, it's 1,000 or EU migrants. And all of this is based on what it's seen before. And it's doing something called linear regression. So I'm sure you've seen a graph before. And if we, like, here's a graph, and actually the computer is trying to predict where the graph is going to go next. So it's predicting that it's that way. And obviously this is a multi-dimensional graph with many aspects, but if we were to bring it back to 2 dimensions, it's guessing that it's going to go down there. And so in this event, that might be cat, that might be dog, and then that might be Matt. And if this made a sentence, but it's basically trying to use the math to say what's the next most likely word. But actually, it's slightly cleverer than that, in that based on a parameter we provide, rather than just saying always nice, it might say hot randomly, it might say cold, and that's to do with the temperature, which is ironic considering that I'm using weather as an example. So this is the ChatGPT playground. And you can see, so I've just told it to finish a human sentence, because the way ChatGPT works is it will once it finishes what it's saying, it will add a special token that means end of response. So I'm doing it on this, and if I set the temperature to 0, this is always going to produce the same result. So in our potential results here, temperature is 0 means always pick the top one. So if I submit this, you'll see sunny, you'll see sunny, you'll see sunny, because sunny is the most common word. So I didn't pick the best one here because I didn't actually know what it is, but sunny. Maybe sunny happens 80% of the time. I mean, maybe it's only just 25, but of all the words that appeared, that was the most common one, right? So just to make it appear at the top of the thing, I'm going to put that. But as we increase this temperature, like if we increase it by 0.1, depending on how common sunny is as the main word, it might not come out of it, because sunny's quite common, like probably, I don't know, 60% of the time, for sake of argument. It happens a lot. But once we start getting higher and higher, we start increasing its potential to drop into other randoms. So if I just jump it straight up to 1, shouldn't really go above 1. Like we should start seeing things like rainy or nasty or sunny. Beautiful. Unpredictable. So that's an example of a token. Right now I've got the maximum length, so that's number of tokens set to 2. So sunny was how the tokens got split up in this example. I imagine if I had 3, that would have been unpredictable. And beautiful today. Those are the next 3 tokens, maybe even beautiful today, full stop. The next 3 tokens that are randomly likely to happen. So I suspect if we change this to the weather is sunny, like the next thing that's going to happen is probably today. Oh, and perfect for. It's quite interesting to see what most common English phrases are. But again, if we don't change the temperature, we're going to keep seeing and perfect for and perfect for. And then once we increase the random, it's going to be picking from that bigger pool of things further down. So sunny and it's. And perfect for, because again, and perfect for is still the most common thing. But so when we're looking at that, with a 0, we're going like this. With a, I don't know, with a 0.2, we might be doing that. Maybe we're doing that, but we're showing how much more of the things we're exposing it to, and how likely it is to drop down the list. But it's still going to favor the most common ones, but we're allowing it to drop into the more unlikely ones by increasing that temperature. So again, and obviously if we were to bump the length up to say 20 tokens, we're going to start to see like much more of the thing. And I'm excited to spend the day outside today. Beautiful. You notice that these have stopped. They haven't stopped at 20, and that's because ChatGPT, specifically ChatGPT, not GPT-3, was trained on conversational data. So what that means is when it had its training data, rather than it probably initially got trained on huge quantities of text like this, just all concatenated together, but then they would have fine-tuned it, so that's some specific training on top that will have been like human. Hello, AI, how are you doing? But additionally, they would have added this extra character, which is just a terminator, and that means I want you to keep writing. So in this instance, if it saw AI, it will go, oh, the next likely. Yeah, actually, it doesn't see AI. It sees all of that. So it sees human, hello, terminator, AI. And it's like, oh, the next thing that I might say from that is how you doing. And it's going to potentially keep trying to guess tokens after that. However, OpenAI see that terminator and they're like, oh, cool, it's predicted the terminator. That means it's predicted the end of what I'm going to talk about. And then we'll pass it back to the human, and the human can then input what the human wants to input. But yeah, going back here, if I increase the length, temperature is 0, just to show you, and a perfect day for the beach is going to come out every time because we've put that as temperature is 0. And that's really how it works. It's nothing more complicated than maths, but it's really incredible what it's shown us, like from training it on these huge swathes of data, like many like terabytes of data, just text. it's been able to produce like stuff that people can believe is a real person. Like, it's absolutely incredible what it's achieved and what it can do. And obviously going forward, we're trying to decide if training it on more data is going to produce a better result, like a wider variation of it. We've already discovered that by training it on code, actually it adds logic to it, and it produces better results because it thinks more logically. Crazy, not something anyone expected, but it had that end result. And then when we move into like multimodal, so that means rather than predicting the next token in terms of text, maybe it could predict the next token in terms of voice, in terms of pictures, in terms of animation. There's no reason it can't do any of those things. And we don't know what it's going to do. We've got high hopes, we've got some great predictions, but it could be incredible. It's already really good, and we can only just train it and make it better and better. Remember, this is version 3 of potentially version 100. Like, the future is very exciting, and I can't wait to see where it goes. But anyway, that's today's video, and I'll catch up with you soon.